Okay. So for this question, it is known that 10% of the patients with high fever are confirmed to be suffering from dengue fever. So 20%, 20 patients, your sample come with 20 people, patients with high fever are randomly chosen. Find the probability they are suffering. 6 of them, less than 6, and exactly 15 that are free from dengue fever. So your situation here, suffering from the dengue fever is your P. Alright, so 10% of it means 10% probability of suffering is 10% since to probability 0.1. So what is your X represent here? First, write your distribution before you start answering the probability. So your X represent the number of patients with suffering from dengue fever. So X distributed binomial with the sample given 20, then 0.1. So for the first, we are going to find probability less than 6. So denoted here, probability X less than 6. So to find this, using binomial, you can use formula, you can use table. So less than 6, if you use table, you need to read more than equal. So how to get more than equal? You want less than 6, but the table only represent more than equal. So we take overall 1 minus the probability, which is we don't need more than equal 6. 6 is not included, so therefore we need to minus, start from 6 onwards. Alright, so refer your binomial table, sampling 20, probability 0.1, page. Alright, so sample 20, probability 0.1. What kind of reading that you want to read? More than equal 6 means read for the reading 6, which is 0, 1, 1, 3. Alright, so when we come to second question, the situation described here is no longer suffering from dengue fever. They are describing here is free from dengue fever, so distribution will be different. So they are taking the opposite way. Alright, so now you're taking Y will be the number of patients which is free from dengue fever. Since we already use X, so we use Y to do the new distribution. Binomial 20%. So free from dengue fever 0.9. Then number 2 here, they are finding how many that are free from dengue fever. Exactly 15. So Y exactly 15. So when we have exactly, we can use formula, binomial formula, 20C 15, P power of 50, Q 0.1, power of 20 minus 15, 5. So make sure your decimal written more than 3 significant figure. Alright, so what can you get here? 0.0319 Alright, so if you don't want to use formula, we have alternative way where we use table. Alright, so this one we use formula. But if you want to use table in this kind of situation, how we going to solve it? In table, we don't have the probability that more than 0.5. Means when you want to find the y equals to 15, we need to reverse the situation. From the free dengue, we reverse to the suffering dengue. So from y, we reverse the situation in opposite way, become x back, so that we can refer this table. So 15, they are free for dengue, means who suffering the dengue, it will be 20 minus 15, which is 5. Then only we can refer this distribution. So how to get exactly 5? We read the table, more than 5 minus more than equals 6. So the reading of 5, 0, 4, 3, 2. The reading of 6, 0, 1, 1, 3. Alright, then continue for question B. B, they change the sampling where 100 patient now is chosen randomly, so approximate the probability that 10 to 15 patients suffering from dengue. So suffering from dengue X, free for dengue is Y. Alright, so our distribution still using X, which is suffering from dengue, but sampling now up to 100%. Then our questions here is finding probability 10 to 15. Probability, the X is start from 10 equal to 15. 10 and 15 included. So we got equal here. Then we read the distribution here. When we sampling n is 100, we notice that the first condition n is large, which is 100. Then we have to double check NP, which is 10. The mean value more than 5 means that binomial no longer suitable for this distribution. So we need to change to normal. In normal, we need variance. Beside mean, we need variance. Variance is NPQ. So 10 times Q, which is 9. Then third condition, we look at the probability where it is in between 0, 1 and 0, 9. So confirm this X need to change to normal. So normal parameter will be mean, which is 10, variance, which is 9. Then based on the question we have here, we have probability in between 10 and 15 inclusive. So we analyze the status of the X. X is originally come from binomial. Where the distribution is not suitable, we fulfill the 3 conditions here, therefore we need to change to normal. So the flow to answer this question will be binomial to normal, answer in normal way, which is change to Z. Then we draw the standard normal graph, then we find from the table normal to get answer. So from binomial change to normal, the procedure we need to do here is continuity correction, CC, whether plus or minus 0.5. Alright, so look at your value here. What do you need is 10 until 15. 10 until 15. So our boundary here, it will start before 10 and after 15.5, which is 9.5 and 15.5. If you choose 10.5, then your 10 will be excluded. Not logic already. Alright, so you can analyze whether you want to start 9.5 or 10.5. If I start 10.5, then 10 is not included, wrong. Okay, so our boundary will be start from 9.5 until 15.5 or 14.5. If we reach until 14.5, 15 not included. So wrong. So means that we have to CC until 15.5. Change from binomial to normal means change from discrete to continuous with decimal. Alright, then after we get normal, we change to Z, standard normal. Standard normal, which is minus mean over standard deviation. Standard deviation, which is 3. So X becomes Z. So for our Z score, how many decimal that we need here? 2. In our table, only showing the Z score in 2 decimals. So when you do your calculation, round off to 2 decimal for Z. Alright, so the first decimal here, the second decimal. So when you round off, what is this? Negative 0.17 and 1.83. So after we get the Z score, we draw the normal graph here, standard normal graph. We identify the area, negative 0.17 until 1.83 in between. So how do we get from the table? Table only showing you the tail side, which is 1.83 tail and negative 0.17 tail. So to get in the middle here, we take overall 1 minus your tail. The tail of negative, we take as positive 0.17. So 0.17, 4325. 1.83, 1.8, go to down here 3, 0.336. So finally 0.5339. Then for the second part of the question B, so this is the first part. Second part, find the value of K such that the probability more than K patient. The probability more than K patient. Change your wording to simple mathematics. Alright, more than K patient confirm suffering from dengue. So suffering from dengue, we use X. Is means equal. The probability is 0.25. So just now, we noticed that our sample is too big, then we change to normal, right? So this one, this question also under the same distribution binomial 100 and then 0.1. So means that this question also in the status of starting binomial. Where binomial distribution not suitable, then only we change to normal. Then continue Z, and then to find from draw, and then we find from table to get answer. So the way to answer number 2 and number 1 is different. This one is finding probability. This one probability is given. This one is finding Z value. Alright. So back to the question. When you want to change to normal, X means we need to do CC 0.5 or minus 0.5. Let's say K. More than K. More than. This K included or not? No, means we can proceed K plus 0.5. Alright. Then we change to Z. From X becomes Z. It will be minus mean over standard deviation, which is 3. So this Z score is unknown. Alright, so this Z score is unknown. We don't know our Z score, so we represent it, let's say a constant A. Then how we draw this? We have to guess what is our Z score A. Whether left hand side or right hand side. Left hand side is negative, right hand side will be positive. So when we guessing here, A, if it is at left hand side negative more than that, can this area fulfill with this value? No, when you have area more than half means your value have to more than 0.5. So this means that our A is not negative. Our A is supposed to be at right hand side. More than that, yes, this area can be fulfilled with this figure 0.025. Kawasan kecil, nilai dia kecil. Kawasan lebih separuh mesti lebih 0.5. Total area 1. Okay? So, with referring to the drawing here means the reading of A can give you 0.025. What is your reading A? We are going to read from the table. From the last page here, this is your probability. This is your corresponding Z score. Alright? So your probability given here is 0.025. 0.025 at the bottom here. 0.025 where your Z score is 1.96 positively. Positively because it at right hand side. The A value is supposed to be positive. So what we represent with the A value just now, the A value is A plus 0.5 minus 10 over 3. We simplify, times back your 3 plus back 10 and then minus 0.5, move it all to left hand side, all to right hand side. K is again 15.38. Then our problem here is, should we round off? Should we round off or we let it to be decimal like this, 15.38? Then you have to refer back, what is your K status? The K status originally is come from binomial. Binomial only for the random variable which is discrete. Discrete random variable, can we accept decimal? No. So means that this K have to be discrete. So when we discrete it, the 15.38 have to round off become just 15. Alright. If our K is come from continuous, then it will be alright decimal. We will accept with the decimal, no need to round off. If the K is come from discrete binomial, yes, you have to round off become discrete number.